Good. Got some more people back on here. Like I said, we're not going to give up regardless of connections or anything like that. Oh, one person. All right. Three people, good. So again, we're not going to give up. Oh, we got more people on. Okay. So we got about the same number of people from last time. So I'm going to just pick up right where we left off. Okay. So we were talking about the problem 5 equals 1y minus 3 5x. And we want to put that in proper slope intercept form. Okay. So what we went ahead and did was move everything around the equal sign so that we can put it in proper slope intercept form. Now, a couple of things in math you just have to assume. Now, we only have about a month left, so some of these things I'm just going to tell you, and you just have to run with it because the amount of time that we have. There's a couple of things we always know. We always know a whole number is over one. A whole number is a fraction. We also know it's a decimal, etc. We also know that anytime we have a variable, there's always a one in front of it. Now, there may not necessarily be a one written out, but there is a one that's there. So, an easy way to think about this problem here, we move the one across the equal sign. That's going to make it a negative one. Okay? Negative 1y. Now, and actually backtrack that. We move it across the equal sign. So now, because we moved it across the equal sign, it becomes negative 1y. This needs to also come across the equal sign. So when this comes across, it becomes negative 5. Okay. People are saying they have to refresh it. Okay. I haven't received any questions so far, so I'm just going to keep going. All right. So we know that this is going to become a negative 5. Now, let's go ahead and put the negative 5 right over here. And we know that this is negative 3 5x. Sweep this up a little closer. Okay. Because this is negative 3 5x, I'm going to write that out. Now, it's okay that this is the negative 3 5x. It's okay this is a negative 5. What's not okay is the fact that we have a negative 1y. We need to make that into a positive 1y. And this is going to be a rule you're going to see a lot in quadratic equations when we're solving inequalities. This is a big rule in algebra. Is when we want to eliminate something, we have to divide it or multiply it by the opposite. So because here they're multiplying by negative 1, that means I need to divide the whole thing by negative 1. Why am I doing that? Because I need to get the y by itself. I need to get the y by itself. So when I divide this whole thing by negative 1, I get y, because negative 1 divided by negative 1 is positive 1. So this is still positive 1, y, equals, now, a negative divided by a negative is a positive, okay? And it's not like math where you can think of, it's not like adding and subtracting where you can think of it as money, okay? This is gonna be one of those few times I'm gonna ask you to memorize this. When we're multiplying signs that are the same, so a negative times a negative, it's always gonna be a positive, okay? If you're multiplying signs that are the same, it's negative times negative, that's a positive. Positive times positive is a positive. It's the same thing when you're dividing. A negative number divided by a negative number is always a positive. A positive divided by a positive number is always a positive. Anytime there's a difference in the signs, like a negative divided by a negative, the answer is going to be negative. So this is going to be, now, because we're dividing a negative by a negative, it's going to be a positive. So it's going to be positive 35x. And negative divided by a negative is a positive, plus 5. This would be our answer. And I know that there might be some confusion because we've been coming in and out of these videos and the connection. I've hooked it up to my phone, so this should be fine now. But again, this is the way that I would like you to solve it. Give everybody a minute to look at that. And I see some people jumping on, jumping off, jumping on, jumping off. Again, if you have any kind of connection issues, shoot me a text because there's more than one way for you guys to get involved with this. I believe it's not giving me the chat feature because of my connection, but that's fine. No matter what, we're going to continue on with class. So again, feel free to shoot me a text. If you would like to call, you feel more comfortable with that, feel free to give me a call. You know, in fact, I think that might actually be easier, I would say, for most of you. So while everyone's looking at this, I'm going to put up the phone number for the conference call. And I'm actually going to log on to the conference call because I know that some of you guys are texting, and I think the conference call is going to make it easier. Okay. So for those of you that are watching, the conference call number is 718-362-6120, and the pin is 161-8044. I'm going to be calling it because I think that some of you guys are going to be more comfortable using that.
Your PIN number. Thank you. Joining the conference now. You are currently the only person in this conference.
Okay. So again, I highly encourage everybody to join the conference call. The number is there on the board. I'll give everybody about 1 minute to send me questions about this. Perfect. We got more people on now than we did last time. Even better. Okay. So again, please use the conference call feature. I know that sometimes that's going to be easier than just sending me a text or shooting me an email. Okay. So the number's up here. If you don't have the number, if you'd like to join, again, shoot me a text, send me an email. A million ways for us to communicate. I'm going to move on with another problem and I'm going to model it from the beginning. Okay. All right. So again, slope intercept form is y equals mx plus b. Okay. So if they give us a problem such as somebody else has joined.
Guilty.
All right. Okay. Perfect. Yeah, I think that might just make it easier because I know that some people had questions that are probably going to be harder to answer through text. Okay. I'm going to send somebody who asked me for the conference call number here, the conference call. Everything that we've gone through so far, does it make sense? Right? Okay. I'm going to mute this. To move signs around after the equal sign because we need to put it in slope intercept form. That y equals mx plus b. Okay. All right. Okay. Can you still hear me? Can you hear me? All right. Can you guys hear me?
We can hear you through the video and the phone now. I mean, I can.
Okay.
I don't know if anybody else is up here.
I know it sounds like two other people have logged onto the conference call. Okay. So slope intercept
We
form.
can hear on the video too.
Okay. So slope intercept form is how we graph everything. It's how we graph linear inequalities. It's how we graph formulas. So anytime they give us an equation that doesn't look like y equals mx plus b, we have to change all the numbers so that it looks like y equals mx plus b. Does that make sense?
Yes. Okay. So the y always has to come first.
Correct. And an easy way to think of it is the y, because they'll try to trick you in a couple of ways. They might put a fraction in front of, well, I doubt they'll put a fraction. That might be like one or two problems, but they're normally going to not give you the y where it's supposed to be. They're not going to give you the slope where it's supposed to be, and they're not going to give you the y-intercept where it's supposed to be. They're going to move it all around to see if you are able to put it back in the right formula. So that's what we're talking about today. So I'm going to try to throw a bunch of curveballs. Yeah. So when you see that on the test, you're not intimidated, because a lot of times people get comfortable with the formula. They take the test and it doesn't look like that. And they're like, whoa, I was never taught to put it back in that formula.
Okay.
Yeah. So the easiest way to think of it is anything that crosses the equal sign. And I don't know how blurry it is. Let me see if I can scoot it up more to make it at least something people can kind of see. When you're looking on the video.
I don't really think it's the connection. I don't think it's anything to do with the distance. It's
just the connection.
Yeah, the picture just keeps breaking up.
Let me see if I can kick something off the Wi-Fi, because I'm using my phone as the hotspot. Yeah, because the local bandwidth just was not working. It kept on saying I had a weak connection. So there's something else connected to my phone. It keeps connecting. Okay, so when you say blurry, nothing can be made out that I have on the board, right?
Sometimes, like for a second, so a split second, you can see blurry, you can make it out, but then it completely like goes away.
Okay. All right, let me see if I turn up the bright.
And everybody else, whoever is on the call, I ask everybody and they all say that it is blurry.
Okay. So there are moments where you can kind of see it, right?
Kind of, yeah.
Okay. So here's what I'm going to do. Once I give this instruction, I'm going to send out a link that everybody can see on their phones and everything else. That's also going to give the same instruction with practice problems. And I'll stay on the line so that you'll have me as a resource, the video, and the practice questions. Because reading will be a little bit easier because we can use ClassKick and I can kind of walk it through that way and we can talk it through together. And for math, I'm going to use Khan Academy as another resource because it offers videos and practice problems. And it walks you step by step if you're getting the practice problems wrong. So it's another good resource. Okay. So anytime that you have anytime you have a problem where you need to graph it, get in the habit of or accept the fact that it's probably not going to be in slope intercept form. That's going to be one of the ways they're going to try to trick you, is by setting it up with everything out of order. So as long as you remember that when something crosses the equal sign, it's going to change. So let's start off with a brand new problem. We're going to have 6 equals -7 over 3x minus y. Go ahead and write that down. I know that the connection is not as strong and some things are coming out blurry. I'm going to give you a minute to write that down. I think I can kick out the other thing that's on the hotspot, and that should make the connection a little stronger.
Okay, I have a question. Does it matter where the x is, whether it's next to the 7 or next to the 3?
It does, because it's a slope. So it always needs to be on the other side of the equal sign. Just the way that you see y equals mx, whatever number has the x next to it always needs to be after the equal sign. Now, does that change the value?
Does it matter whether it's the 7 or the 3 that you put the next, 7/3?
Yes.
Does it matter whether?
Yes, it matters. So let's say, for example, in this case, it's a -7/3, right? Well, because it's already next to the equal sign, at this point, I don't have to change it yet because it's in the right place. So that is okay. But when you look at the problem that I gave you, what is not okay about it? What do we need to change?
Well, the y on the other side of the equal sign.
Good. Now, what do we know is always in front of the y?
1.
Good. So it's actually really negative 1y. So when I bring it across the equal sign, what is it going to become?
Positive.
Correct. It's going to become a positive y. So it's just going to stay the same. Now, what about that 6?
It's going to be negative.
Correct. And that 6 is now going to move to replace where the y was. So it's now negative 6. And what about the 7/3 3? I'm sorry. What about the negative 7/3 x?
That stays where it is.
Stays where it is, stays the same. And now it's in proper slope-intercept form. Yeah. And there are multiple ways to do this. And when we start talking about inequalities, there's going to be multiple ways. So sometimes the videos and the things that I sent out are going to give you a different way to do it than what I showed you. But I do that on purpose. So if the way I showed you is easier, then use that for the practice problem if it makes more sense. If the resources that I'm giving you make more sense, then use the strategies they give you. Because there's multiple ways to do this, right? So they may not even have you move it across the y. Now, let's take that same problem, because I know not everybody can see, and let's change one thing about it to see how comfortable we are. So instead of a y, negative 1y, let's say it's plus y. So it'd be 6 equals negative 7/3 x plus y. How is that going to change the whole thing?
Is it going to turn into a negative y?
It is.
So it'll be y equals negative 7x3 negative 6.
Okay, now you said that when the y goes across the equal sign, it becomes a negative y, right? So it'd be negative 1y equals negative 7/3 x minus 6. Now, can we have the y be negative? Is that the way the formula works? No. So what are we going to have to do so we can take this and make it into the slope-intercept form?
Divide it by negative 1.
Divide the whole thing by negative 1. So if we divide the whole thing by...
You don't even need to take this test. I mean, just...
You know what I've noticed?
So it'll change the negative 6 to a positive 6.
There you go.
Plus 6.
Yep, so it'd be y equals positive 7/3 x plus 6.
Positive on the other side?
No, the 7/3. Ooh, I love it. Okay, I'll let you explain it. Go ahead. Love it. Go ahead.
Let's just say that the 7/3 never moved, so it stays the same. The only thing that's changing is the y and the 6.
Well, the 7/3 is going to become positive because you're dividing the whole thing by negative 1. Mm-hmm. Yeah, because if you divide one part of the equation by something, you have to divide everything by it. So as long as you remember those two things, when you move across the equal sign, you become the opposite. That's just a math rule. I'm not going to go into like the numeracy behind it and all of that. Just understand if it moves across the equal sign, it's going to become the opposite. So when it becomes the opposite, now I have everything where it's supposed to be. The problem is that the value of where it's supposed to be is wrong. Like the y can't be negative because that's not actually slope-intercept form. So because the y can't actually be negative, I divide the whole thing by negative 1 so that I can put it in slope-intercept form. And there's all kinds of little rules that people use. Some people will just say, move it across the equal sign. And then if it's a negative that's across the equal sign with the y, make everything the opposite. There's a million ways to think of it. I like the fact that if I know there's always a 1 before the variable, before that y, because all these letters in math represent variables, if I know there's always a number before it, it's easier in my head to be able to say, well, I need to get rid of this -1. It needs to become a +1. And because I'm dividing this by -1, the whole thing needs to be divided by -1. You might remember this from school where they say, whatever you do to one side, you have to do to the.
Other side.
There you go.
Who else is on the call?
I have 4 people total. People have not joined.
Brandy, are you guys here?
Yeah, Danny and Brandy, if you're able to hear me through the live stream, please join the conference call, because especially if we happen to lose connection or anything like that, then I don't have to worry about continuously sending out the text messages. I can just tell you, hey, go subscribe, and the new video will be there, and it'll be easy for me to answer questions. I don't see me losing connection with this, but I do see that the video is probably going to be a little blurry. So it'll be easier if we are able to talk through it, and then I can give you more resources that way. Okay. So for the people that are on the line, is it easier when we move on to doing the practice problems in Classic? Is it easier that I text you the link to do that, or that I email you the link?
Probably text, because the emails, I haven't been getting your emails. Luckily, Ildy's been sharing them with me, so.
Okay, so the text messages are easier?
I got the first one, but all your emails yesterday, I didn't receive any of them.
Oh, okay.
I would like them emails because I'm on the computer and I can't click on a text on the computer, so if that's okay.
Okay, I'll send it through both then. I'll send it through both.
Thank you.
Yeah. Do we have any questions so far about how we work this out?
No, I'm glad we went over the -1x, because I was thinking the first time you went over it that it was kind of dumb and that we didn't need it. But now seeing that that 7, the -7x3 is affected by it, becomes positive. Help me out.
Okay, yeah. There's a lot of things in math that are assumed that I noticed when I was a student, that the teacher's just like, oh, everybody would know there's a 1 there. Oh, everybody knows that every whole number is also a fraction and it's over 1. And that's what usually makes it a problem, because if I didn't know that, that's a lot of little like math games to play. And that's where it becomes difficult. So I try to really use logic and very little like memorization. Like moving things across the equal sign, we're pretty much memorizing that. And that's okay, because that's only one part that we're memorizing. Everything else, we understand why we're doing it. Oh, looks like somebody else just joined. All right, who just joined the conference call?
Me, Cora.
All right, so we got 3 people on. So 3 people out of the 4. All right. Okay. And I know, Corey, everyone else is telling me that it's blurry. Are you able to make out anything that I write on the board?
Yeah, it goes blurry and then it kind of is up.
Okay. Did you have any questions about changing the formulas to slope-intercept form? Changing the equation, should I say, to slope-intercept?
I think I got it.
Okay.
I understand it.
All right. Now, because everybody got it, now we're going to make it harder. All right. So now we're going to do the same thing with inequalities. Okay. So I'm sure everybody's heard the word inequality. You probably hear a lot with like race relations and stuff like that. Like things aren't equal, or you hear about like gender, things are not equal, inequality, right? In meaning the prefix, meaning the opposite, right? So in math, we like to graph inequalities as well. So we're going to talk about how we graph inequalities. And then I'm going to show you how they're going to try to trick you with that as well, because there's also little things they're going to try to do to throw you off with that. Okay, sorry. Keep getting other messages. And if there's anything that doesn't make any sense or something that you haven't seen in a while, please ask, because I purposely start off with these again because it hits multiple areas in math. So I'm like, okay, if they're not getting this, they're going to understand this. All right. So let's look at a sample problem. Okay. And this one, I'm going to give it to us in perfect slope intercept form. We don't have to move anything. So let's say it's y is, let's just say, greater than 5x plus 3. Everybody have that? Okay.
5x. Yeah.
Yeah. So it's going to be y is greater than 5x plus 3. I know that the video comes in and out, so I'm also going to speak it or pronounce. I'll say it out loud. Okay. So I'm going to draw a quick graph here. And on my graph, and again, and as I'm saying it, I want you to do it with me, especially since the connection is weak. So we're going to create our own little graph on paper. And in fact, since we're all on the conference call, once we graph this, I want you guys to shoot me a text showing me what you guys graph. Shoot me a picture. Okay. So we know that we're going to start off on the y-axis, which is vertical, and we're going to find the 3. So we're going to put our pin where the positive 3 is. What are we going to do from there?
We're going to go to the right, positive right, 5.
Do we go to the right 5 or do we go up 5?
Go to the right side.
Yeah, we always go to the right, but we have to rise over run, right? So 5x is our slope. So 5x is nothing more than 5 over 1 because it's rise over run. So I'm going to go and take that point and I'm going to go up 5. 1, 2, 3, 4, 5. And how many times am I going to run? 1. So I'm going to put another period there, another point. Now,
stay on the y.
What's that?
Okay, so we put the 3 on the y, and then we go up on the y 5.
And you go over 1. Because it's rise over run.
So like if it was like the last problem, 7x over 3, then we would go up 7 and over 3. Yeah.
Does that make sense so far?
Yeah.
Okay.
I was just confused. I thought that the 5 goes to the right first, and then the 1 goes up 1.
Yeah, anytime you're talking about going up or going down, you always move to the right. So your run is always to the right. Does that make sense?
Yeah.
So let's say it was like 5 over 3. We'd always run to the right. If it's negative 5 over 3, we would always drop to the right. Does that make sense? We always run to the right. I make the test. And the more that you stick with rules that are easy to follow and remember, these, you're going to see a lot of these. You're going to see these as inequalities. They're going to ask you to put it in slope-intercept form. They're going to ask you to graph it. So I always like to stick with simple rules. Like, if you notice, rise starts with an R. Run starts with an R. The right also starts with an R. So it's quick, easy things to use for the test. Rise over run and go to the right. Yes. Yep, it's always over 1. And those are those little math games that I think a lot of times teachers don't talk about. They're like, oh, everybody knows it's over 1. Well, that's not true. So that's why I always look at it that way. And if you're ever confused on a fraction, think of it this way. So a fraction is pieces of a number. And I hope that this drawing comes out clearly. So 5. I'm going to partition this 4 times. 1, 2, 3, 4. See how I have 5 pieces? Does everybody see that on the YouTube live stream? Box.
Yeah, just a little slow.
Okay. So when I shade them in, it represents the fact that when I have these 5 pieces together, I have 1 whole. Right? So I have I have 1 whole that is made of 5 pieces. That's a way you could think of a fraction. Let's say I take out 2 of these little pieces. Well, then this fraction is going to change. Out of my 5 total pieces, how many do I have shaded? 3. So it'd be 3/5. Mm-hmm. Just another way to look at a fraction. Any questions about the fraction? No. Okay. Perfect. And I can see why it's doing that now, why it's like becoming clear and going blurry, because it keeps telling me it's losing connection, then reestablish on my phone. So that's fine. Then I know that if you can hear me here, you can ask questions here and you can kind of see what I'm drawing. All right. So let's go back to the problem. Now, we have it in perfect slope intercept form. We plotted our 2 points. What's the next step we would normally take?
You draw a line.
Correct. Now, so anytime that we just have an inequality sign with no equal sign, when it's just greater than or less than, our line is going to be dashed. And that means that when we're talking about what would work, it's not solid. I mean, well, the numeracy behind it is that because it's a greater than or less than sign and it's not equal, it's not going to completely work. Think of it that way. That's why it's dotted. If you want to memorize it, anytime you see greater than or less than and you're graphing, your line is going to be dotted. So it's going to be like this. I'm not an artist. Please excuse my crooked line. All right, but it's going to be dashed.
Is that the only difference?
Yes. For now. We're about to get a little crazy in a minute. All right. Oh, and someone just sent me a picture. Perfect. Yes, please shoot me a text with a picture of what you worked on. Perfect. Okay, who is this? Just send me that. Okay, this is Ildi. Okay, perfect. Thank you.
Yeah.
And so I still haven't heard from Danny. Who else? Yes. Your name is Coral, correct?
Yeah.
Okay. Yeah, so we're working on paper to shoot me a text.
Is there any time that the y is not greater, it's less?
Yes, and that's what we're going to talk about. Now, as far as graphing it, that's not going to make too much of a difference when it's just greater than or less than. Let's say I change this to be less than. It's not going to change the way that I graph the line. At this point in the game, at least. Okay, I just got another response. Okay. And I saw somebody roll, it's going to be dashed or dotted. Just remember that anytime we're talking about just greater than or less than, it's going to be um, dotted every time. That's a math rule because we're not using an equal sign, so it has to be dashed because it's not including everything. That's why we have the equal sign when it's exact. This is not exact. We're not including everything, so the line is going to be dashed. Makes sense so far? And there's only one person I haven't received a response from. Okay, so I got a response from Coral, LD. I haven't heard from Danny yet. I'm going to give you guys about like 2 more steps, and then I'm going to send out some practice problems that we'll do till about like 11:30, and then we're going to move on to reading. Reading will be easier because what I'll do is I'm going to send out a link for ClassKick so that I can see everybody working, and then we'll also have the conference call up so you can send me a message or type the message in ClassKick, and I'll keep the live stream open too in case there's questions, so I can use as many tools as possible. Danny, are you still with us?
Yeah, I'm still here.
Okay. And are you sending me that picture of your graph?
Yeah, I already did
Oh,
like 5 minutes ago.
how come I didn't get it? Okay. It's like I didn't get it just yet, but that's fine. Did you have any questions about it?
No, pretty easy.
Okay. So we're going to move on. It's going to become harder. Why? Because the devil's real and he hates us. So now we're going to make it something else. All right. So obviously we have more than just greater than or less than. So now we also have equal to. And that's another line below the inequality. Now, what that is going to change is the fact that whenever we have that equal sign, our line is now going to be solid. We're not going to have a solid line. So I went ahead and I added the equal sign, just one line below it, to change this equation. So now it's going to be a solid line. We're going to be adding a little bit more.
Less or equal?
Yeah, so this would be y is either less than all of that or equal to. So y is either less than 5x plus 3 or at most it is equal to 5x plus 3. That'll become important later on when we start plugging in numbers to see if things are true or not true. If the inequalities are true, that means that whatever number I plug in there will actually make this work. Or if it's not true, meaning that I plug in this number and it's not going to work. And then later on, we'll be graphing it.
So is there anything we're doing right now with this?
Yes. I just want to make sure that we don't have any questions about why it's solid. Does anybody have a question about why it's solid?
Why is it solid?
Okay. It's solid because of the equal sign. When you see the equal sign with the greater than or less than, anytime you're graphing that, it needs to be solid. When it's just by itself, the greater than or the less than, it's going to be dashed.
Okay.
If you want the numeracy, the math logic behind it, the equal sign is a very powerful sign in math, and that means that something will work. So that's why it's solid. The inequality signs are like more like limits as opposed to a constant thing. If that makes sense. If you just want to memorize it for the test, then if it's greater than or less than, the line is dotted. If it's an inequality with that equal sign, it's going to be solid. Okay. Oh, now I just got it, Danny. Okay, thank you. Know why? Okay. All right. So there's still more. Okay. So what we're going to do now is it's going to ask us to shade what will work and will not work. Okay. And there's a lot of ways to do this. You can plug in the origin. Do you guys remember what the origin was? Okay. The origin, and this is going to be important. There's a couple ways to do it. The origin is the point, is the ordered pair 0 and 0. That's the origin.
Oh,
yeah. That's going to be very important when we're talking about graphing, because the origin is where everything comes from, point 0 and 0. All the numbers come from there.
Well, the middle.
Correct. And it's called the origin. I'm big on using the terms because when you test, they're only going to give you the terms. So the more you get used to hearing the terms and knowing what they mean, it's going to make the test easier. Because I've noticed that some teachers like to just call it things, and then that sets you up for failure because they have proper names on the test. And if you don't know the proper names, it's easy to get confused. The only time I'll tell you to memorize something is when it's a math trick, and I try to really limit those because they're not always helpful. The only time I'll tell you to memorize everything is if you completely don't get it, then I might just say, hey, memorize these steps. And that's what's known as an algorithm. That's the way math was taught before. But that's not helpful. It's only good in a last-ditch effort so that we pass. So there's a couple of ways for me to shade, to know what to shade, okay? There's a good rule. If you decide to memorize things, you're like, hey, I just want to get in here, pass. I'm going to give you an easy way to memorize it, okay? Anytime that we're talking about greater than, where the y is greater than, see in both of these, the y is greater than. Anytime that the y is greater than, we shade above the line. All right, we shade above the line. So I'm pretty sure you know what I'm about to do. So anytime that it's going to be y is less than, right? Whether it's y is just less than or y is less than or equal to, we're going to shade below the line. Oh, and while I'm doing this, did everybody get a chance to go on the website and fill out the attendance?
Yes.
Okay.
No, I didn't do it yet.
Okay. Yes, please go on there, sign in, and then sign out at the end of the day as well. We got about an hour left. Okay, so given this rule, where am I going to shade? On this equation we've been working with. Y is less than or equal to 5x plus 3. Where am I going to shade?
We're going to shade the 3 and the 4th quadrant.
Good. Below.
I mean, the above.
Are we going to shade below this line or above this line? Below. If you want to know why we're doing that, just understand that this is a formula to see what numbers will make the formula true, like what will actually work, and that's why we're shading. This is really important when it comes to again, traveling in space, or if we're trying to use a rocket for something. it's really good because in the real world, at least, I was trying to give you the real world side of it. It can be helpful to know if you're going to hit a certain point or if something is within the trajectory of a rocket or something like that. Will you ever use that in the real world? For most of you, probably not, unless you're like in engineering or, yeah, pretty much engineering, or like if you're doing some kind of like rocket science, I would imagine. I'm sure there's more examples of how it applies in the real world, but for the vast majority of us, it's not going to apply. So this is probably the easiest way to think of it. You look at that inequality sign that lets you know whether you're going to shade above or whether you're going to shade below. Questions about that so far?
Do we only shade that triangle, or do we go into the other quadrant?
That's below the line. Everything that's below the line. So if you notice on my figure, I shaded everything below the line. Any questions? Okay. Now, if you want to know another way to do it, maybe you want to have another tool in case it makes it easier. You can also use the origin to figure out what area to shade. All right, you can also use the origin. So here's how we use the origin. The origin is what two numbers?
0, 0.
Correct. The ordered pair is 0 and 0. Now, if I plug this back into my equation and it's true, then I would shade below the line. If it's not true, I would shade above the line. And again, if this doesn't help you, that's fine. I'm just giving you another way to do it. Both ways are perfectly fine. So let's look at an example of that. So y is less than or equal to 5x plus 3. Well, let's put the 0 in for the y. Let's put the 0 in for the x. So 0 is less than or equal to, well, 5 times 0 is what?
0.
0. 0 plus 3 is what?
3.
So is it true that 0 is less than or equal to 3?
Yeah.
Yes. So because it's true, I would shade below the line. That's another way you can do it. That'll actually be helpful if they ask you to shade and they give you the equal sign. You can use the origin. But that, again, that's later on. But it's another tool that you have. Somebody just sent me a question. It's going to be everything below the line. Okay. Everything below the line. Okay. So because this is a true equation, I would shade everything below it. Now, let's just, for the sake of fun and games, let's just say that I'm going to switch the inequality sign. So let's just say now that I want to make it so that it is greater than or equal to 5x plus 3. So all I did was change the sign. It went from y being less than to y being greater than. So let's say I did that. Y is now greater than or equal to 5x plus 3. So what am I going to do? Same thing. Plug in my zeros. 0 is greater than or equal to 5 times 0 is 0 plus 3 is 3. Is this true that 5 is greater than or equal to 0? I mean, 0 is greater than or equal to 3. Is that true?
No.
So where would I shade?
Above the line.
So that's another rule that you have. Question so far? All right. Now, on the practice problems that I'm going to send out to you, you're going to see them give you values for y and values for x. And they're going to go in more depth. I kind of want to see what you guys prefer because Khan Academy is a great resource. And if we like it, I can assign that for homework. So they might say something like, let's say that 5 is x and y is 3. Is this equation true? Well, let's see. 5 times 3 is 15, right? 15 plus 3 is what?
8.
What is it?
You said plus 3, 8.
15 plus 3.
Oh, 18.
Correct. And y is 3. So is that true? Is it true that 3 is less than or equal to 18?
Yeah.
Yes. So you know that those could be 2 points that could be found. Right? And let's see if that's true. 1, 2, 3, 4, 5. And then 1, 2, and 3. Yeah. Okay. So just think of it that way. So you're going to see something like this. Now, they might give you one value and they'll want you to solve for the other value. All right. But I'm going to see how well we take instruction from the video on that because I want to see if we're comfortable with it. Before I send out the link for graphing two variables and graphing inequalities, do we have any questions?
I'm good.
Okay. So I'm going to copy this link. There's no need to log in. Is there anybody who's, I think it was Danny from before. Besides Danny, is there anyone who's just using a cell phone?
I'm on my tablet too.
Okay.
Yeah, I'm on my computer.
Okay. So the tablet should work fine with Khan Academy. If for some reason you see that it's not compatible, like you're not able to solve problems, it's not letting you enter in the answers, then let me know because I can put up sample problems up here on the whiteboard and we can work it out together that way.
So are we doing all three, the conference, the YouTube? And
Yeah, I'm leaving it all out there. So there's multiple ways to ask questions, multiple ways to get help, the whole nine. Yeah, so no one can say they can't get help. What I would like you guys to do is to use, if you have the tablet alone or a computer, I would like you to work on it on your own. Now, if you notice again that you're not able to see the videos, it's not letting you enter in the answers, then let me know and I'll start putting up problems here on the board. If you are solving a problem, you don't understand it and you want help, then we'll go ahead and solve it together on the board. The nice thing is that in this portion of math, everything has a pretty much exact answer. It's not always going to be that way. So I just sent it out as a text message and an email. I'm sorry?
Is there a link we're clicking right now?
Yes, I sent it out as an email and I sent it out as a text message.
Okay. Yeah.
You're very welcome. So to keep us in the habit of being on a timer, I'm going to put a timer up and I'm going to give us about 15 minutes to watch the videos and complete the practice problems. If you're smoking it, all the way at the bottom left of Khan Academy, there's going to be like an arrow or a button you can press that'll give you another lesson. If you killed it, you're getting the practice questions right, go ahead and move on so you can get as far as you can for the next 15 minutes.
How do we get to the practice questions?
So on the left, when you press the link on the left, you're going to see where it says intro. That's a video. Graphing. That's a video, and you'll see the little triangle. The practice is where it says practice graph of inequalities. And you can click on that and do the practice. Yeah, you're very welcome. Mm-hmm. And the two variable inequalities, that's a little bit of what I started to get into with the X and the Y. That'll be a brand new lesson you guys can do with them. I want to see if you like it. If so, I'm going to send you guys links to Khan Academy before I teach something. That's called blended learning, so that you're able to see it before we start it. So you can come to me, and then if you don't have any questions, if it's teaching you, then we're going to move right on. So we can really take advantage of every minute of this month that we have before the class ends. So I'm going to put 15 minutes on the timer. And at the end of 15 minutes, we'll come back. If you have a question in the meantime, feel free to let me know. This could also be your rest if you haven't had a chance to. Again, I always like to use the clock because I want to put the pressure on, because that's the way the test is. They're always going to have a clock. Everything is timed.
So do we start now?
Yes, go and start now. You got 15 minutes. The video is only like 3 or 4 minutes long. Inequalities before the two steps. So what do they say there at the end? What's that? Sorry, I know someone's talking, but they're coming in kind of muffled.
Oh, I couldn't hear it. Background. I couldn't hear it either.
Oh,
I remember him saying not to be a skeptic of ghosts because nothing's certain in the afterlife. Or
yeah.
something
He
like
says
that.
in the afterlife, there's no such thing as a non-believer.
Oh, yeah.
And then what happens to the guy?
He burned.
He burns. So because he burns,